Hello, 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 hello. Right, yes, we're live. Good. Okay, so I am, as the title says, designing a PCB for. Oh no, don't play just yet. I'm designing a PCB for my computer case, which I'm in the process of modernizing. There is a video, which I will link in the description, showing what I've done to it so far and comparing an old one in comparison. Now, if I go to this PCB designer, what is the what's the let me just have a look at what's the aspect. I think this is 1920 by 1080, right? Let me have a look at the stream audio recording or no stream output. Look, I don't know. Suffice to say, you'll have to bear with me, right? So if I zoom in, we can see what I've got. So I was in a discussion with my dad about designing this. A motherboard front panel. Can I show you a motherboard front panel, for example? I know. Let's show you a motherboard front panel. Because this will help explain what I'm trying to do. Motherboard front panel. In fact, you know what? MSI B350 Tomahawk front panel. Right, so images. Ah, yeah, is that my motherboard? Oh, look, doesn't matter, right? You'll have to deal with some abstractions here, right? Motherboard front panel connector. It has various things you plug in: power and reset switch, power LED, and a drive status LED, which sort of flickers on and off based on drive activity. Now, I like the idea of taking the 5 volts, so that's the 5 volt signal from the drive status LED, and I'm sending it through a diode, which, now the reason you send it through a diode is so that you don't get feedback. Now, a transistor, this one over here, that will not send power back. It won't feedback, but just to be doubly sure, you put a resistor and a diode in there. Now, why do you put the resistor in there? So that you don't feed too much power to the base. And when I first designed this, I thought, I know what I'll do. I'll have the light bulb down here because surely you want it to be the emitter. And then my dad said, actually, it's a lot better. I don't remember exactly why he said put the xenodiode in, but I did. It's a lot better if you have the light bulb at the collector, and then what it does is the light bulb is an unusual type of resistor. It draws a lot of current when it turns on, and then the resistance goes down as it warms up. But either way, it acts as a resistor, which then prevents too much current going to the transistor. So yeah. Now, let's say there was no transistor here. It'd be very simple. You would have power going to the light and then down there, and that would then turn the light on. I mean, it's a circuit any child has done where you connect a light bulb to a battery or you connect it to a bench power supply. But in this case, I want the light bulb to be switched on by the drive status indicator, and that's why I'm doing this extra stuff. So I said to my dad, all right, I've got this, this wire here that goes from the motherboard front panel to the base of the transistor, which he recommended a BD135, because he said, oh, well, look, even the light bulb I mentioned, when it first starts up, you're looking at about 5 amps inrush current. So He says a BD135 should cope with it, but if not, there's other NPN transistors I can use. And now it comes into here. All right, that was it. Yeah, I was saying to him, well, look, I've got the wire that's going from the motherboard front panel to there. And then I assume the ground path, could it go from base to emitter to ground? And he says, yeah. But he also said, no, what you want is a wire going from 5 volt plus to the base with the diode and resistor in place to limit current. And he says what you do is from base to ground, the return ground on the motherboard, you put a 1K resistor in there and do that. So this is my wiring diagram. Right, I've explained the circuit, and now I need to show you some pictures. So can I show you some pictures? Yeah, you know what? Let's do an image slideshow, shall we? I think this is how to do it. So if I do an image slideshow, and I will do, yes, and image files, we add it from, so if I go to pictures, and I go to Shark side panel, right, this is everything I need. It's open, okay, and then, right, here we go. So you should be seeing it now. I've got this on the screen. And that there is showing the PCB, the daughter board, which connects into the side panel. And I was measuring it. It's 5 centimeters across. You know what? I've got the damn thing in front of me here. But yeah. So in addition to that, right, so what we'll do is we'll just... Oh, can I shrink you? It's not... Oh, it's only letting me shrink in this way. Why can't I change it? What if I do transform? Will that do it? Transform. Stretch to screen. Yeah. There we go. I know. Right, so let's stop this for a second. I'll just delete it. Delete. Right. Delete. Right, there we go. Anyway, so if you're wondering, I'm doing this as a live stream because then I can open this up to anybody that's interested, really, and may offer advice. I'm going to... Unfortunately, I'm learning as I'm going. So, God. Slide mode, visibility, behavior, fade, transition speed, whatever. My time between slides like 10 seconds. So 10,000 milliseconds, right? And I don't want it 920 by that. I want it slide mode. No, transition. Is there a way I can change that? Oh, sod it. Look, I'm just going to put in a number myself. By 1024. Right, there we go. Right, add image files. Add files. So I'll have the pictures back. Right, okay, open. Okay, yep. So there we go. And if I put this just here to the side, so you can see I'm using these for a reference. Now, can I show you the scan I've just done? I'm doing some cardboard aided design. So I've made a template, and oh yes, it's a PDF. So here it is. Now, OBS won't display a PDF, so what I'm going to do is if I make it, oh come on, like so. I can save this folder. I'll save it in other, right. And then pictures, shark side panel, and open, right? And we'll save it as that, right? Now if I go as image slideshow, we'll add one more. So add a file, screenshot, right? And what you'll be seeing eventually is my card aided design, and that will come in useful later because it's a cardboard cutout of the PCB, and it's also got a notch in it which corresponds to the height of the side panel. Right, so I've done all of that. I've shown you the diagram. I think it's time to do FreeCAD. So we'll do FreeCAD, and yeah, FreeCAD. Oh. Bear with me. My coffee's just sort of wearing off at the moment. Maybe I should be using not PCB calculator, PCB editor. That's what I want. Right, okay. Yep. So let's have you look at the PCB editor. We'll do another window capture. Yep. And we'll do what's this called? I've got so many windows open. I'm a bit of a PCB editor. Yep. Okay. Oh. Why are you so massive? Transform. Fit to screen. There we go. Right. Is there a thing where I can import from bitmap? Graphics. File. No, it doesn't want to import from that. Is it a bitmap thing? Oh, why don't we start with some... God, you know what would be really nice? If I could just scan this in. You can't look at what I've got in my hand. Right, I need to show you what I've got in my hand. That's what I've got in my hand. I've got this board, right? It'd be really nice if I could just scan this in and say, bear with me, I'm thinking in my brain. It's hard to explain, right, because I'm talking at the same time. Place. Let's start with that. We'll add a... Oh, you need to see what I'm doing, don't you? Right, so let's rename that to circuit diagram. All right, and then we'll rename this one to PCB design. Right, and then if I move PCB design to the top, right, now you can see what I'm looking at. Right, so if I go place, add, not microwave shape, add footprint, yes, and we'll look for USB. Yeah. Oh, you can't see what I'm looking at. Choose footprint. So let's bring that up so you can see what I'm looking at. Choose footprint. There we go. And yep. Okay. And we'll make this bigger. So, right, if I type in, let's have a look. No. Ah, that is a single stack, and it says vertical. Right. No, it's not USB Type B, so it's a Type A. Yeah. And can I make this bigger? Yeah, you can't see what I'm doing there. Well, that's better. So now if I do, let's transform this fit to screen so you can see what I'm looking at. It's a double GAN connector. Hang on. Let me have a look at that. I'm reading here. Use the connector USB library to add the right angle SMT USB-C. Oh God, so many choices. No. Oh, sod it. Look, this isn't the right one, right? But I'm gonna put it down here, and this is just gonna be a placeholder. So, oh, you can't see what I'm doing because you're still looking. That's all right. The window's gone. Okay, so you can see what I'm doing. So, can I rename this? I don't know what this stuff is. Bear with me, right? Bear with me. Next, we'll add a USB-C connector. That's right. So we'll place and we'll add a footprint, and it's USB-C. You can't see that, so let's make sure you can see. Choose footprint. There we go. So it's a USB-C, and it's a vertical connector. I think this one might be the right one. Shenzhen, Jingtao. Yeah. So we'll put that in. The thing is, it's not a vertical connector what we're using. We're using a right-angled connector. So let's see if I can find a right-angled connector. So we'll go place, add footprint, and then we'll go to, you need to see what I'm looking at. Choose footprint. There we go. Right. It needs to look like a right-angled connector. And all of these, they're not right-angled connectors. They're like things which go, no. Filter USB-C, right? No. Yes. Almost. Oh, sod it. I can always just replace these afterwards, right? But, I mean, that, for example. USB-C receptacle. Vertical, yeah. USB-C receptacle. Do you know what's really annoying about this? I was on Mouser Electronics and they said, oh, we've got an ECAD here. Do you want this ECAD object so you can add to your design? I was like, yes, I would like that actually. Right, well, let's just go with the first one I saw, which was the Shenzhen thing. That's it. Right, we'll place that and it will go here. And then I need to do... now, I'm going to use the via, so I'll place a via. And it's not... oh, well, actually, no, we got a circle. Yeah, I'll use a circle. And these are placeholders. It's literally just going to say, well, this will be where the thing is on the motherboard. Why won't you draw? Oh. 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 Well, look, it was there, 3.592 millimeters. That's almost the same size as the 3.5 mil jack. So we'll do Control C, Control V, all right. Now, if I bring up the image slideshow, and you're looking at the rear of the thing, so the one that's closest to the firewire connector, which is going to be USB-C, is the pink microphone, and then the other one is the green line out. So I'll put that there. By the way, hello Ian, hello Alphabet Cat. The death of Gonch. Who's Gonch? I don't know who that is, but you know, rest in peace, as they say, to Gonch. Right. So, right. That's actually. You know what? Can I? There we go. Now, properties. Its color we're going to use as. No. These line style is fine. Line width. I was wondering if there was like a thing which lets you change colors, but it doesn't. So, right, and this board is 5 centimeters across. So that connector. I mean, I don't have a ruler in front of me. My God, I need some like set squares and rulers and things. I've got a vernier. Yeah, let's use a vernier. Where's my vernier? I know it's here somewhere. Did I put it in my toolbox? Bear with me. Hobbit's looking for a vernier. Look, whilst I'm doing this, I'm going to listen to some my music, right? So you are going to listen to my music too. Right, can't find my vernier. Doesn't bloody matter. Fact is, the reason I'm putting these placeholders in is they're standard reference sizes, and I know what sizes these are. Oh God, it would be so nice if I had my vernier, because then I'd be able to measure these distances. Like, I mean, I can guess them. So I guess all I need to do now is place and add a field zone. Yeah. No. Place, add rectangle. Or draw a rectangle. And that says, so it's 50, and in fact it's exactly 50 millimeters. Can I edit this? Bear with me. Music time. I need to concentrate. that is all the placeholders I know. Now, I'm not sure if you saw it. I was looking for, if I go to place, add footprint, I was looking for USB headers because if you can see, let's bring up the image slideshow. Come on, let's bring you to the top. Eventually, it will get round and it will show you that. It's quite interesting. So the USB header, as you can see, is it's 9 pins because of the key in there. The firewire is just 6 pins, and then audio is also 9 pins, but it's keyed different to the USB. Well, it is on the motherboard header, but these have the same keys, which is confusing. Now, I was hoping to find something that looks like that. Ah, do you know? I've only noticed now on this PCB you've got you've got resistors. I can't read those values, and you've got a capacitor. I wonder why that is. Either way, it's very interesting how it's done. Now, I think the more exciting thing, and therefore the bit which is more important. So we've done the PCB design. That's great. We'll close that for now. Yeah. We've had the circuit diagram. Oh, what's this? So what am I looking at now? Let's close. I'm going to start closing things now because I've got too many things open on the screen, and it's you know what? I had to have a long call with my dad about what I was trying to do and explain it to him, and my brain is sort of not working too good. It's all right. As long as the brainards work, then it doesn't matter if they don't work too good. So we'll add a new window capture. We're going to call this one FreeCAD. Yeah. Okay. And it's going to capture part design example. FreeCAD. Okay. Yep. And it's huge. You know what? Transform. Yeah. You know what? I'm going to redo the stream, right? Because I think this bit is. I'm not sure what size my canvas is on OBS. And the only way I can edit that is if I end the stream. So I'm going to be right back, and I'm going to have the stream in 1440p. So I'll be right back. Oh, I haven't stopped it.